Hello, and welcome back to Quantitative Skills at the University of West Georgia. Today's lesson is about problem solving. This corresponds to section 1.4 in the textbook. We're going to be looking at word problems today. I want you to remember as we go through today's lesson, the goal is not to solve these specific word problems. The goal here is to make word problems less scary. We're going to give you a set of steps you can follow so that when you see a new and unfamiliar word problem, you have a way to gain a foothold, break it into manageable parts, and solve the problem, instead of being intimidated by the problem. So we're going to do 3 word problems in increasing order of difficulty, meant to demonstrate a set of steps that can help us solve these word problems. Go ahead and log into your course den. In Course Den, in the Content section here, you're going to go down to Handouts, and you're going to select the handout 1111 Modeling. Modeling is the art of translating a story problem into an algebra problem. While every problem is different, you can treat the 6 steps below as a helpful template to help try to solve new or difficult problems. So again, this is to try to give you a foothold in these problems. What can I do to break a word problem into parts instead of staring at an empty page? So I'd like you to pause the video, go to your course den, and open up this document. And you should have this open to refer to throughout today's video. We're going to take 3 story problems through these 6 steps and see how they play. All right. So you can pause here if you want another minute to read this document. Otherwise, I'm going to jump right into the first story problem and try to apply these steps. This first one's pretty easy, but we're going to use it as a model to see how these steps go. It goes as follows. 2 numbers add up to 42. Their difference is 18. What are the numbers? So, look at your modeling handout. Step 1 is to understand the problem. We'll read the problem once to see what it's asking. 2 numbers add up to 42. Their difference is 18. What are the numbers? Now we're going to reread the problem and mark down what are the unknown quantities and what are the relationships given. So an unknown quantity would be a value that I don't know, but that it could be helpful to know. In this case, there are 2 numbers. We can go ahead to step 2. These steps are not meant to be solved strictly consecutively. You can kind of merge them together. Step 2 says to assign variable names to the unknown quantities. So you can pick whatever you want, x and y, a and b. I'm going to use a and b, but you use what you like. Looking back at step 1b, we should also note relationships given in the problem. I'm going to use red for relationships. A relationship is anything that helps me relate one unknown quantity to another, or relate them to a known quantity. In this case, telling me that they add up to 42 is a relationship. Telling me that their difference is 18 is a relationship. In general, I should have as many relationships as I have unknown quantities. So in this case, with 2 unknown quantities and 2 relationships, I am ready to go on to step 3. What we're doing here is taking notice of the parts of the problem. We've broken the problem into parts, and now we're going to translate the parts into the language of mathematics. So we're translating from English to mathematics here. When it says 2 numbers add up to 42, I want to write that as an equation. I'm going to write a plus b is 42. It says that their difference is 18, so I should write something like a minus b is 18. Now I'm done with step 3. It's time for step 4. Use your equations to rewrite all unknowns in terms of one variable. Here's what that means. I've got these 2 equations. Let's say I take this second equation and I try to solve for a. It doesn't matter which equation you take or which variable you solve for. That's just the choice I'm making here. So I've decided to take the second equation and solve for a. I would add b to both sides to make it say a equals 18 plus b. Okay. Notice how when I solve the equation for a, the answer has a variable in it. It's 18 plus b. I still don't know what number a is worth. And so just trying to solve one equation does not get me to a value for a. What I can do in step 4 is rewrite all unknowns in terms of one variable. Now I know what a is in terms of b. I can replace every a I see with 18 plus b. So I'm going to take this other equation, the one I haven't used yet, whichever one that is, and where it says a plus b is 42, I'm going to replace a with 18 plus b. Whenever I replace something this way, it's called substitution, because I'm substituting one thing for another. And I always like to put what I'm substituting in parentheses. It's not necessary this time, but in the next problem we'll see we need to. It's a good habit to get into. So I put parentheses around the new value of a. A is worth 18 plus b. So instead of a plus b is 42, 18 plus b is 42. That's step 4. Step 5 says solve the remaining equation for the one variable. You can see we've now got an equation here that only has b's in it. A is gone, it was substituted out. Since this equation only has b's, if I can solve for b, I'll get a value for b that is a number. It won't be in terms of a. So that's what I'll do. B plus b is 2b. I have 2 b's, so that's 2 times b. I write 18 plus 2b is 42. Now I use the method of algebra. Say, do you know what language algebra comes from? The word algebra itself. You might be thinking Greek. Lots of math words come from Greek, but not this time. It's actually 2 words, al and gebra. Al is Arabic for the, and gebra is Arabic for balance. While Europe was in the middle of the Dark Ages, the Arabic-speaking world was making innovations in math. A mathematician named Al-Khwarizmi came up with this method of algebra, the balance. The idea is to think of one of those old-fashioned balance scales. This is the kind where there's a central pivot on a pillar, and this bar can rock side to side, up and down, side to side. And so if the weights I put on the left side are heavier, the left side will sink. And if the weights I put on the right side are heavier, the right side will sink. If those 2 weights are exactly the same mass, the 2 sides will be balanced and they'll be level with each other. So Al-Khwarizm's idea was if I put 18 plus 2b on one side of the scale and 42 on the other side of the scale, this equals sign indicates that those 2 sides are balanced. And he had this brilliant deduction. If I lift 18 pounds off the left side and 18 pounds off the right side, the resulting scale will still be balanced. So as long as I do the same thing to both sides of this equation, I get a new equation that also represents balanced scales. On the left, I have 2b, the 18s are gone. On the right, 42 minus 18 is 24. I write equals to say that the scales are still balanced. So that's the method of algebra. That's what algebra really is. This deduction dates back almost 1,000 years ago. Second, if 2b weighs the same as 24, if I cut the weight of each side in half, the resulting scales will still be balanced. So b is equal to 12. If I do the same thing to both sides of the equation, then the scales will still be balanced. So now I know that b weighs 12 pounds. That's the only possibility if 18 plus 2b weighs 42 pounds. All right, I hope you enjoyed that little history lesson. What's important for today's problem is that we found out b is 12. We're now done with step 5. We solved the remaining equation for the variable. Now I know one of my numbers is worth 12. Step 6 is where we finish up. So in steps 1, 2, and 3, we translated the English into math. In steps 4 and 5, we processed the math and solved it. In step 6, we're going to finish solving and translate back to English. Translate your solution back into the language of the problem. 6a says to solve for any remaining unknowns. So I know b is 12, I need to know a. I can pick either of these two equations, where it says a plus b is 42 or a minus b is 18. It doesn't matter which one I pick. I'll use a minus b is 18. I'm going to substitute again. This b is 12 is going to replace b. So now this equation says a minus 12 is 18. I'll add 12 to each side, and now it says a equals 30. So now I know my other number is 30. 6b says write your solution in English. If you were trying to pass through the gates and the riddler at the gates said, first you must solve my riddle. Two numbers add up to 42. Their difference is 18. What are the numbers? You wouldn't say b is 12. The riddler didn't ask about b. You would say the two numbers are 30 and 12. So there's our solution written in the language of the problem. We've translated that from math back to English. 6c, reread the problem with your solutions inserted as a check. 30 and 12 add up to 42. That's true. 30 and 12 have a difference of 18. That's true. 30 minus 12 is 18. What are the numbers? 30 and 12. So our solution has passed all of the conditions given by the problem, so now we know it's a correct solution. In this case, since we had two equations and two variables, our solution is probably, almost certainly, unique. It is the correct solution. If you had more equations than you have variables, you might not be able to find a correct solution. If you have more variables than you have equations, you might not be able to narrow it down to one correct solution. But if you have the same number of equations as variables, in the vast majority of cases, there will be exactly one correct answer. And we found it. So again, the goal was not to solve this particular rather easy riddle. The goal was to get used to using these 6 steps. Again, you should be looking at this handout that you got from Course 10. The goal was to use these 6 steps to solve the problem. And if you're just skipping ahead in the video, again, those steps are here on Course 10. In content under handouts named 1111 modeling. 1111 is the name of it's the course number of my college algebra class. I teach from this same handout in college algebra. The only difference is over there we do problems that require quadratic equations. In quantitative skills, we won't use quadratic equations. Are you ready for another problem? You can pause the video if you're not. 5 consecutive numbers add up to 365. Okay, let's see an example. What do consecutive numbers mean? 10, 11, 12, 13, 14. That's an example of 5 consecutive numbers. Each one is one more than the previous. Now, these 5 numbers add up to 60, so they're not the solution to the problem. But that's what I mean when I say 5 consecutive numbers. Okay, let's try to solve the problem. Underline your unknown quantities and give them names. You can use whatever names you want. I'm going to use A, B, C, D, and E. Now underline your relationships. Since there are 5 unknowns, there should be 5 relationships. Here's one. They add up to 365. So A plus B plus C plus D plus E adds up to 365. Where are our other 4 relationships? That's right, they're hidden in the word consecutive. If these numbers are consecutive, they're like 10, 11, 12, 13, 14. What could you say about B? That's right, B is one more than A. You could say C is one more than B. But, what if we try to start on step 4 as we finish step 3? Instead of saying B is one more than A and C is one more than B, I'm looking ahead. I think it would be nice to write everything in terms of A. Write everything in terms of one variable. So thinking ahead to step 4, As I'm writing my equations, C is B plus 1, D is C plus 1, and E is D plus 1. There I have 5 equations for 5 variables. Since these are consecutive, I add 1 to get from one letter to the next. So these 4 red equations represent these 4 red arrows. But I want to write everything in terms of A, so instead of saying C is B plus 1, if B is A plus 1, then C is A plus 1 plus 1. In other words, C is A plus 2. Does that make sense? A plus 1 is B, B plus 1 is C. Put it together, C is A plus 1 plus 1. A plus 1 plus 1 is C. Following the same logic, D is 3 more than A. So we can write we can write D is A plus 3, and E is A plus 4. All right. Now I've written B, C, D, and E in terms of A. So I need to rewrite all unknowns in terms of one variable. I've done so. Now I want to get this down to one equation for that one variable. I've used all of this to write everything in terms of A. The only thing left to use is this. It says A plus B plus C plus D plus E is 200, I'm just going to rewrite it. It says A plus B plus C plus D plus E is 365. We are going to substitute these 4 factors. A plus, instead of B, I'll write A plus 1. C, instead of C, I'll write A plus 2. D, instead of D, I'll write A plus 3. And E is instead A plus 4. Those add up to 365. Now, my equation has just one variable in it, A. We can drop these parentheses. When I substitute, I always use parentheses, which means I broke my own rule. I should have put parentheses here. See? Right there. But they weren't necessary. These aren't necessary either. It's a good habit to get into. In the next problem we do, they will be necessary. But right now, we can drop the parentheses. Go ahead and gather all the A's together. You wrote A 5 times. That means you have 5 times A. Remember, multiplication is repeated addition. If I add the same thing 5 times, I have 5 of them. And 1 plus 2 plus 3 plus 4 is 10. All right, now you can use Al-Khwarizm's balance method, the balance. By the way, any word that starts with al is likely to be an Arabic word. Can you think of any? Like alchemy means the chemistry. Al Jazeera means the news. Scientists think that almanac is probably from an Arabic word, but no one knows which one. The original has been lost. Okay, so back to the problem. 5A plus 10 is 365. If we lift 10 pounds off each side of the scale, it will remain balanced. 5A is 355. Now divide both sides by 5. Well, let's see here. Can I do that in my head? 350 divided by 5 is 70. I know that because 35 divided by 5 is 7. And there's one more 5. 5 divided by 5 is 1. So 355 divided by 5 is 71. That's the end of step 5 for this problem. We solved our equation for one variable. Now we need to translate our solution back into the language of the problem. Solve for any remaining unknowns. A was 71. B was 1 more than A. So B is 72. C is 73. D is 74. And E is... I didn't need to write that. E is 75. There's 5 consecutive numbers. The 5 consecutive numbers are 71, 72, 73, 74, and 75. That's our solution in English. Now let's reread the problem with our solutions inserted as a check. The 5 consecutive numbers, 71, 72, 73, 74, and 75, add up to 365. Well, is that true? If I add these together, 5 70s makes 350, and the remainder is 1 plus 2 plus 3 plus 4 plus 5. That's 15. So yes, that adds up to 365. We solved the problem. It's time for our third problem. Remember, you're always welcome to email me if you didn't understand something in a video. My email is nrehfuss@westga.edu. Okay, feel free to ask questions. I can even record more videos if you need to see more details. All right. Our third problem today, I've decided to do 4 instead of 3, incidentally. Our third problem today has to do with money in a cash register. My till cash register contains only $5 bills. I'm just going to write 5s and 10s. There's no 1s, 20s, 50s, or 100s. Only $5 bills and $10 bills. All right. There are 8 more 5s than 10s. My till contains $340. How many 5s are in my till? Can we solve this question? This is going to be a little trickier, and when we do our substitution, we will need our parentheses. So, my till contains 5s and 10s. There's 8 more 5s than 10s. First off, let's reread the problem and make sure we understand everything. And let's start underlining unknown quantities. How many 5s? That's a good question. Say I call it F. Maybe not F. F means something else in math. Let's call it X. X is simple. X 5s. What else do we need to know? What else is unknown right now? That's right. How many 10s are in the till? It doesn't say how many 10s anywhere in the problem, so I'm just going to write it here. How many 10s? We'll say Y. On second thought, my Y's look a little bit like 4s if I write quickly. I'll use lowercase, then it looks distinct. So instead of an X, I'll use a lowercase x. We have X 5s and Y 10s. There are 8 more 5s than 10s. There's a relationship. There are means equals, than means equals. 8 more 5s than 10s. The number of 5s is larger than the number of 10s. If I take the number of 10s and add 8, I get the number of 5s. Now, you might be wondering, how are you so sure that that's the right way to write the equation? I wasn't sure how to write the equation. How do I know for sure? Maybe it should have been x plus y is 8, or x plus 8 is y. I know I'm adding 8 to something, but I don't know what. Here's what I'd say to you. We're going to put some crash test dummies into the problem. We're going to make up fake values of x and y. They won't be the right answer, but they will help us write this problem. So let's do some fake thinking. Fake numbers. There are 8 more 5s than 10s, so let's start with the number of 10s. Y equals, what if there were, what if there were 2 $10 bills? How many $5 bills would there be? You know how to do that. There's 8 more 5s than 10s, so there would be 10 5s. Now let's check our 3 equations. The first one says 2 plus 8 is 10. That's true. The second says 2 plus 10 is 8. That's false. And the third says 10 plus 8 is 2. That's false. So now I know this is the only correct one. If your numbers, through bad luck, happen to satisfy 2 equations, just pick different numbers, and then you'll see which one is right. So now we know one of our equations is y plus 8 is x. If I take the number of $10 bills and add 8, I get the number of $5 bills. There are 8 more 5s than 10s. My till contains $340. That's the other relationship. Oh, that's tricky. What equation do we write this time? Once again, we're going to do fake numbers. Let's make up something totally arbitrary. Let's say that y was 2 10s. I don't need to satisfy the first relationship anymore. Let's say that x was 3 5s. I think you can probably tell me how many dollars 2 10s and 3 5s is worth. If you think about it for a second, you'd probably come up with 35. I'd like you to pause the video and ask yourself, how did I get $35? Where did I come up with $35? Well, write it on your own page, but I'm going to give the answer now. You probably said there's 2 10s and they're worth $10 each for $20. There's 3 5s and they're worth $5 each for $15. So 35 is 20 plus 15. Let's take it down another step. Let's step into the computation. You had 2 10s worth $10 each, so you did 2 times 10 to make the 20. You had 3 5s worth $5 each, so you did 3 times 5 to make the 15. Almost there. 2 and 3 were fake numbers. Let's replace them with their variables, and then we'll have the equation. Instead of saying 2 10s, you have y 10s worth y times $10. You have x 5s worth x times $5. And in the real problem, they're not going to be worth 35. They're going to be worth 340. It says so in the story. My till contains 340. So your equation is 340 is y times 10 plus x times 5. I'm going to follow the normal convention and write 10y plus 5x. Normally when we multiply a number by a variable, the number comes first. So that's what I'll do. Okay, we have 2 letters and we have 2 equations. We are ready for step 4. Step 3 is finished. We used our fake numbers. Let's bubble those off so we don't accidentally think they're real. We used fake numbers to come up with these equations. Now we can say, all right, if y plus 8 is x, I have an easy thing to substitute. Where I see x, I'll replace it with y plus 8. Then I'll have an equation with just one variable. So 340 is 10y plus 5 times, and now we need these parentheses. All of x got multiplied by 5, and x was y plus 8. So both the y and the 8 need to be multiplied by 5. In our next step, we're going to simplify the right-hand side. 5 times y plus 8, we can distribute the 5. If I have y plus 8 boxes and each box has 5 balls in it, I have 5 y balls in the y boxes, and 5 times 8 is 40 balls in the 8 boxes. I have 5y plus, excuse me, that's not right. I have 5y plus 40 balls. So both terms that were added together, both terms need to be multiplied by 5. If I have y plus 8 $5 bills, then I have 5y plus $40. Next step, we're going to keep simplifying the right-hand side. 10y plus 5y is 15y. Now we're ready to use the balance scales. Take $40 off of each side. The balance scales should still be balanced. Divide both sides by 15. 300 divided by 15 turns out to be 20. So y is 20. We finished step 5. We solved our remaining equation for one variable. We have one more thing to do. Step 6, solve for any remaining unknowns. I know that there are 20 $10 bills. I want to know how many $5 bills, and I know there's 8 more 5s than 10s. Using y plus 8 equals x and substituting in 20, I get 20 plus 8 is x. So 28 is my value for x. Now I can say it in English. I have 28 $5 bills. Let's reread our problem with our solutions inserted as a check. My till contains only 5s and 10s, 28 5s and 20 10s. There are 8 more 5s than 10. That's true. 28 minus 8 is 20. My till contains $340. Is that true? Well, let's use this math again. I have 20 $10 bills worth $200. I have 28 $5 bills worth, I don't know 28 times 5. I do know that 28 times 5 is the same as 14 times 10, because 14 is half of 28 and 10 is twice 5. That's a fun math trick. So 28 times 5 must be 140. And 200 plus 140 is 340. So we got the right answer to this problem. All right. Hopefully now you're seeing how we can use these 6 steps to make our way through any kind of story problem, even a story problem we've never seen before. I've got one more for you. Jim is at the park playing with his dog. The dog's name is Snuffles. Here's Snuffles. Jim calls Snuffles to go home. At this point, Jim and Snuffles are 300 feet apart. Jim is going to start walking at 2 feet per second. Snuffles is going to run towards Jim at 10 feet per second. What I'd like to know is, how far does Snuffles run? Snuffles is going to stop running once Jim and Snuffles reach each other. They're walking right toward each other. So how far does Snuffles run? Okay. We need to put variables to our unknown quantities. How far does Snuffles run? That's an unknown quantity for sure. Maybe you could call that x. Jim is going to be walking. Maybe we can write another variable for how far Jim walks. We could say Jim walks y feet. Snuffles runs x feet. One tip, if you're having trouble with a physics problem, is to try drawing a diagram to help you. So I'm going to draw a number line. Here's 0, 100, 200, 300. Since Snuffles is going to run x feet, if I mark x right here, then Snuffles runs from 0 to x. So I'll put Snuffles at the 0, and I'll put Jim at the 300. So Jim goes y feet and ends up here. This gives me an idea for a relationship. If Snuffles goes x feet, and Jim goes y feet, and together they cover 300 feet, then it must be true that x plus y is 300. I know I want to solve for x, so I'm going to substitute away the y. I'll write y is 300 minus x. Jim walks 300 minus x feet. So you see, now that I've got the hang of my 6 steps, I've started working out of order. These aren't rules for a story problem, they're guidelines for a story problem. So now I have one equation and 2 variables. Y is 300 minus x. I still don't have enough information to find x. I need to use the rest of the information in the problem. Snuffles' speed and Jim's speed. I haven't used that information yet. Looking at your sheet, it says, write all relationships as equations in step 3. This includes relationships explicitly stated in the problem, as well as common formulas related to the subject of the problem. So if your problem had the area of a rectangle, you might have to bring in area is length times width. If your problem had a circle, you might have to write area is pi r squared, right? If you're working an interest rate problem, you might need to pull in simple interest is principal times rate times time. These formulas will usually be found somewhere in the chapter of the textbook that the problem you're solving is from. If you're in a chemistry class, look in that chapter of the chemistry textbook. If you're in my finance unit, look in the finance chapter of your textbook. In this case, we're solving a physics problem, so we should think about physics formulas that might work for a distance and a rate, a velocity. I'll give you the formula. The physics formula we need is distance equals rate times time. Distance is rate times time, often abbreviated d equals rt. If you got this problem in a physics class, you would see this story problem in the chapter where the textbook lists d is rt somewhere in that chapter. So let's think about Snuffles and Jim's journeys in the context of distance is rate times time. I told you to draw a diagram. Here's another piece of advice. If you've got a lot of information, Snuffles makes a d is rt, and Jim makes a d is rt. Let's draw a table to try to organize all our information. So I'll mark distance, rate, and time for both Snuffles and Jim. I know Snuffles goes x feet. Jim goes y feet, but we can simplify things. We know that y is 300 minus x. So Jim goes 300 minus x feet. For the rates, we were told that Snuffles runs 10 feet per second and Jim walks 2 feet per second. How about the time? Here's what I know. When Jim and Snuffles meet, that's it. When do Jim and Snuffles meet? They will both stop walking at the same time. Let's call that time t. We had to introduce a new variable to finish our equation. Sometimes step 3 helps you solve step 2. Since d equals rt, I know I need to have a variable named t. And the key here is that Snuffles and Jim stop moving at the same time. So we'll put t in both boxes. Snuffles goes x feet at 10 feet per second in t seconds. Jim goes 300 minus x feet in t seconds at a rate of 2 feet per second. So we can write d equals rt for both people. For Snuffles, distance equals rate times time. For Jim, distance equals rate times time. Let's take a look here. At this point, we have two unknowns, x and t. Y has been eliminated. We have x and t, and we've got two relationships. We have the right amount of information to try to solve this problem. So, x is 10 times t. That looks like a good candidate for substitution. X is already solved for. So we're going to take the other equation, 300 minus x is 2t, and proceeding on to finishing step 4 and getting into step 5, we're going to substitute x for 10t. This time I don't need the parentheses, not like last problem, but it's still a good habit to include them. If you don't need them, it doesn't hurt anything to put them anyway. We can just erase them in the next step. Picture your balance scales. On one side is 300 minus 10t. So 10 balloons each pulling with t pounds of force against a 300-pound weight. On the right side is two weights that each weigh t. What are you going to do? The same thing to both sides. Let's add 10t to both sides. That way all of our t's will be gathered on the right side of the equation. 2t plus 10t is 12t. Now we can divide both sides by 12. and then t will be by itself. It turns out 300 divided by 12 is 25. I know that's true because 12 quarters is $3. 12 times 25 cents is 300 cents. That's just serendipity. That's not a good trick for dividing by 12 in general. But we got our answer. T is 25. Excuse me, we got our answer to step 5. We solved our remaining equation for the one variable left in it. This is the equation starting step 5 with just one variable remaining, and now we have the variable. Jim and Snuffles will meet 25 seconds after they begin moving. So what's missing? 6a, solve for any remaining unknowns. Now we know t is 25. Let's look back at these equations. The first one seems simpler. I could substitute 25 into either equation, but the simple one's easier. The first one looks easier to work with, so I'm just going to pick that for my own convenience. X is 10 times t. All right, x is 10 times 25. Snuffles will run 250 feet. How about Jim? Well, Jim's distance, y, is 300 minus x. Jim will move 50 feet. All right, let's write our solution in English. How far does Snuffles run? Snuffles runs 250 feet. C, let's reread the problem with our solutions inserted as a check. Jim, walking 2 feet per second, at a rate, Jim's rate is 2 feet per second. Jim covers a distance of 50 feet in 25 seconds. And that's true. 50 is 2 times 25. So D equals RT is satisfied. Snuffles covers 250 feet at a rate of 10 in 25 seconds. We can check 250 is 10 times 25, so once again, D equals RT is satisfied. All right. Remember, the goal of this exercise was not to be able to solve problems about running dogs. The goal is to get comfortable with these 6 steps as you try to solve story problems. Go ahead and open up your 1.4 homework now. You'll see 5 story problems. Try to solve them with the 6 steps listed here. Again, remember, you don't have to go totally in order. You can give them names as you're in the middle of 1B. You can give them names as soon as you see them, the variables. In 3, sometimes writing a relationship gives me an idea for what variable to name. I didn't know that time would be relevant until I remembered distance is rate times time. In the future, if you're ever stuck on a story problem, start underlining unknowns, and if you can't come up with enough of them, look in the textbook for formulas that might relate to the problem, and see if the variables in those formulas would make good unknowns. Okay, I hope this has been useful to you. That's all for today's video. Take care, and I will see you again soon.